So the most important part of the scientific process is publishing your results. So like Galileo is really famous, but he wasn't actually the first person to do what he did. He was just the first person to publish it. And so he's remembered, but even though somebody else did what he did before. And so your results are only important or meaningful in the scientific context unless you publish them. So I spend a lot of my time preparing my data for publication, getting it ready for publication, submitting it to scientific journals, and actively participating in disseminating the scientific knowledge to other scientists so that they know what's been done and they can build upon that knowledge. Research papers are pretty formulaic, so scientists like the information in the same format every time so they can easily understand when other people present new data. So all research papers have an introduction, a methods, a results, and discussion. So the methods and results are easy to write because the methods are what you did and then the results are just what you found. So it's just like a picture or some graphs of, so those two sections go together. The methods are what you did and the results are actual results of what you found with little interpretation. The introduction and the discussion section also mirror each other. So the introduction section of the paper tells, it helps put the context around why you're doing the measurements and what other people have found and kind of the holes in the scientific literature that your paper hopes to answer. And then the discussion section talks about the results and then puts those results in the broader context of what you talked about in the introduction. And so just as the results are what come out from the method section, the discussion mirrors the introduction section and talks about how what you found then adds to the scientific literature and the importance of what you found as you set up in the introduction. A lot of science fair projects are set up to show, hey, this is always true, and look, I showed it's true. I think in real science and in good science fair projects, you show when something's true, when something's not true, and why it is that way. It's really nice if you can show the limitations of when something's true, and then have a theory about why it works in some cases but not other cases. That's usually a good like recipe for a scientific paper for a scientist is this is true now, not true then, and this is why we think it's true now and not then. So, I mean, if you could do that in a science fair project, that would be awesome.
Visit the Natural Enquirer website for more information. There you can learn more about explaining your results and sharing them with others.